The formula for kinetic energy, Ke, is equal to half times mass times velocity squared. We're going to use this formula to work out the mass of a vehicle. We'll be given initial kinetic energy and final kinetic energy, and we'll be able to work out the difference and then work with these equations to find the mass of the vehicle. Okay, so a car moving at 5 meters per second is accelerated to 12 meters per second. So we're given the change in kinetic energy to be 20 kilojoules, and we're asked to determine the mass of the car. So first of all, we can work out the initial kinetic energy. We weren't actually given this, but we can work it out because it's half times mass times velocity squared. We don't know the mass of the vehicle, but we can say that the initial kinetic energy is going to be 12.5 times the mass of the vehicle. That's given our initial velocity of 5 meters per second. Next, we work out the new kinetic energy, half times mv squared. This time we use the 12 meters per second in our formula, and we can work that out to be 72 times the mass of the vehicle. So now we have two ways of expressing the kinetic energy: 12.5 times the mass of the vehicle and 72 times the mass of the vehicle. What we also know is that the change in kinetic energy is 20 kilojoules. So if we subtract the new kinetic energy, if we subtract the initial kinetic energy from the new kinetic energy, the change should be 20 kilojoules. So Ke2 minus Ke1 is equal to 20 kilojoules, or 20,000 joules. Let's develop that a bit further using our values for new kinetic energy, our new expression for kinetic energy and initial kinetic energy. So 72 times the mass minus 12.5 times the mass equals 20 kilojoules, or 20,000 joules. So hopefully at this stage you can see that we're in a position where we can start working out the mass of the vehicle. So 72 minus 12.5 is 59.5 times the mass. So dividing both sides by 59.5 gives us the formula for the mass of the vehicle: 20 kilojoules divided by 59.5, which is 386.13 kilograms.